Going to talk some about ratios and proportions. A ratio is a comparison of two numbers using division, shows the relationship between them. A proportion is two equal ratios. When we talk in a proportion, it can be written out as a logical string, or it can be written as two fraction form ratios. We say it the same way either way. A is to B as C is to D, or A is to B as C is to D. The parts of the proportion have names that we use to refer to them. The two numbers on the inside in the middle are called the means. Now you're accustomed to mean meaning the average, the arithmetic mean. We also have the meaning here. There are many meanings of the word mean. Generally, it refers to something kind of in the middle. So here in the middle are the two numbers in the middle. The other two numbers that are at the beginning and at the end also have names, and they are called the extremes. You don't say a extreme or a mean. You talk to them. You talk about them as pair. The pair in the middle are the means, and the pair that are not in the middle are extremely far away and are the extremes. It's more obvious when it's written in this fashion than it is when it's written in the fraction form, but it's nevertheless here B and C are the means just as here, and A and D are the extremes. Notice that we're talking here about the location of the items. It is not about value. It is about the location, not how much they're worth or how big they are. So the means and the extremes are the ways that we refer to the parts of a proportion. Well, let's work on a proportion here and see how it goes. Well, let's see. Maisie and Percy need dog food. Who are Maisie and Percy? They are my dogs, and they eat a lot of dog food. Maisie's 90 pounds, Percy's 110 pounds. That's a lot of dog food. So let's make some little charts, some proportions, some T-charts to try to set it out. Always do a 2 by 2 comparison and write the words. I ask you to do this not because proportions are hard, because they're ridiculously easy. Once they're set up correctly, it's simple to solve it. But there are certain predictable mistakes that you can avoid by just going through the exercise of tracing through exactly what you're doing. Yes, I know you do it, but you got to do it anyway, because you're going to make predictable mistakes, and don't want you to do that. So let's say on the dog food, we're comparing the amount in the bag and the price of the bag with the small size of bag and the large size of bag. Okay, let's say small bag of dog food's 20 pounds and the price is $25. The large size is 80 pounds and the price is $100. Typically one of those will be a variable that you're solving for, but nevertheless, here we have our proportion. Notice that the proportion that you're looking for is inside the chart with the two circumstances in two different items in two different circumstances, two different conditions and two different circumstances. Always set it up that way. Always rehearse it in your mind so that you won't make the common mistakes, which are really, really easy to make. Well, let's play with this proportion a little bit. Handy thing about proportions is you can write them in different fashions and they still work. So let's say instead of saying amount and price, what I happened to think of was price and amount. So I'm going to write the same one in a different order. Also the small and the large container. Rehearse in your mind the price of the small one, $25. The price of the large one, $100. The amount in the small one, 20 pounds. The amount in the large one, 80 pounds. Again, this is your proportion. Now look at this, see where everything is located, and see how this one differs from this one. First off, notice they are not the same ratio. They are not the same relationship between the numbers. This one reduces to 1 out of 5. This one is 5 out of 4. It's not the same relationship. However, they are both valid proportions that get the same quantities. When you look at it, you notice that they're all flipped. Both ratios are flipped. That one's 4 out of 5. I said 1 out of 5. Yo, okay, 4 out of 5. 4 out of 5 and 5 over 4. I'm sorry. So we have a fancy math word for flipped. It is reciprocal. So we see that with a proportion, you can take the reciprocal and it will still be a valid proportion. It's not the same relationship. 4 out of 5 is not the same as 5 out of 4. But nevertheless, it's a valid one that can be used to solve this and get what you need. Okay, so what if I thought of small and large first, and I put those on the left, and that leaves amount and price to go here? How would that work out? Okay, well, talk yourself through it. The amount in the small bag, 20. The amount in the large bag, 80 pounds. The price of the small bag, 25. The price of the large bag, 100. I just did that wrong. I wasn't paying attention. Okay, 25 and 80. Oh no, that's right. Oh, sorry, yeah. Okay, 10, yeah. Again, we have another proportion. This one is a valid one as well, but it's not the same. This is 4 out of 5, 4 to 5, 5 to 4. This is 1 to 4. Look at the original, look at this new one, and tell me what's different. You'll notice that the means are in a different location. The means are switched in location. It is nevertheless still a valid proportion and still works for this circumstance. So we notice that it is acceptable to switch the means of a proportion, and it will still work for us. So we have here some things that we can do. With proportions, you'll need to make note of these. And also, why don't you pause the camera and try to figure out why the bottom one works. Why does the bottom one work? Try to figure it out. Okay, you'll notice in the bottom one, what you're essentially doing is add 1 to each side. So we start with the relationship A is to B is C is to D as an equation. Add 1 to each side. A over B plus B over P. Remember, if you're going to add, it needs to have a common denominator. So 1 can be expressed as B over B, giving us A plus B over B. Same thing for C over D. To add 1 to it, we'd need to express the 1 as D over D to give us this. Now this might look less useful than the others, but it really does come up a lot of times that it's useful. Like if you're making punch and you want to know how much punch there is, if you're going to put in lemonade and blueberry juice and you want to know how much total punch you're going to get, sometimes this might be a useful way to use the proportion. Different ways to work it out. Those of you who learned the butterfly method of solving proportions, you now officially can't say that anymore. The way to say it is cross products. So please work these two problems. You work the bottom one too if you want. These two problems. So you might want to pause it and work it. And here are the solutions that you get. Notice that on the second one, it turns out to be a quadratic. So remember your basic algebra skills. That is, you multiply out, don't forget you got to put parentheses, And you're going to get a squared term, makes it a quadratic, and you have to remember that the way to solve a quadratic is to set it equal to 0 and find the two factors. I can factor. AC goes at the top, B goes at the bottom. You multiply to get AC, you add to get B. So this factors out to two responses, A equals 5, A equals -4, one or the other. As in all quadratics, or anything where you come out with where you start with a variable in the denominator, you must check to see if there are any invalid answers. In other words, if you try both answers in, make sure you don't get a 0 denominator. Here you do not get a 0 denominator. There are two correct answers. Next, we'll talk about geometric mean. The geometric mean is another kind of mean. It's another type of middle. It's when the means of a proportion are equal. How would that look? A is to X as X is to B. So we have two numbers, A and B, and X is the same number both places, and it's the geometric mean, so that it makes a valid proportion here. Well, let's work one out. Let's do the geometric mean of 12 and 27. So 12 and 27 then will be the extremes. We'll place those in the location for extremes. So it'll be 12, 27. And then the means are the same thing. As we solve this, we see that x squared equals 12 times 27, which is 324. The square root of both gives us that x equals 18. Well, I wonder if that works. So I'll put it back in and see. If I have 12 is to 18, as 18 is to 27. Yeah, that reduces to 2/3. That reduces to 2/3. Yes, that is a valid geometric mean. So if you would practice and do these. After we get those, then we'll notice the pattern for how the geometric mean works, and that is that the geometric mean, which must be positive, because it's not going to be between if it's negative, the geometric mean is the square root of the product of the extremes. Let's go back and look at the TV shapes, the movie shape. This rectangle has an aspect ratio when you make it a decimal, which is about 1.3. That's the old TV. The new TV is about 1.8. It turns out that if I just ask you to draw a rectangle and you're just drawing one, you're not wise to me. The one that most people will draw most of the time has a particular ratio to it, and it's about 1.6. It is so common that people choose that as just a really good looking rectangle. It's also everywhere in nature, and it's everywhere in art, and it's used so much that it has its own name. It's the golden ratio, and this is how the golden ratio is shown. A plus B is to A as A is to B. Here we have our first rectangle, the pink one, A to B, then A plus B to A. We can keep doing this, many iterations of it. As we draw around at the midpoints, it will curl around and it will actually become the shape of a conch shell. It's very common in nature, something you ought to know. The letter that we use for it is phi. This is how it's calculated, and it's approximately 1.6. So that, for the moment, is just an interesting bit of trivia about ratios of triangles. The golden ratio, it's just very pleasing to most humans. It's present very frequently in nature and in art, the golden ratio.